Welcome to The Explainer. I am so thrilled to have you here today. Look around the room you're sitting in right now. Have you ever wondered how all those objects surrounding you actually came to be? Well, you're in exactly the right place. Today, we're unpacking a really fascinating foundational chapter, all about manufacturing industries, the literal economic engines that build our modern world. We're going to see exactly how these massive systems work from the ground up. Okay, let's get right into it. We're drawing directly from our source material today, which is a comprehensive textbook chapter that covers the whole shebang, everything from local, single-person artisans, all the way up to massive, sprawling steel plants. It's an absolutely brilliant breakdown of what we call secondary economic activities, and we're going to map it all out together. Here is our roadmap for today. First, what exactly is manufacturing? Second, why is it the backbone of development? Third, how do we classify these industries? Fourth, the environmental cost. And finally, finding sustainable solutions. All right, part one. What is manufacturing? Let's get our basic definitions straight before we look at the heavy machinery. Basically, manufacturing is all about transformation. It's a secondary activity. You take a raw primary material, like, say, a chunk of wood or some raw sugarcane, and you add a ton of value to it by turning it into paper or refined sugar. You aren't just moving stuff from point A to point B. You're actually making something entirely new, and usually you're doing it in massive quantities. Our source actually shares a really great little story to ground this concept. It talks about a young boy named Harish who goes shopping for Diwali. He's amazed by the sheer volume of stuff in the market, and his dad points out that everything they see comes from a totally different scale of manufacturing. Think about it. The shoes and clothes you're wearing, probably turned out by massive machines in a large-scale industry. Your kitchen pans, maybe made in a small industry. But those beautiful, intricate earthen lamps, the diyas, those are handcrafted by individual artisans right in their homes. That's a household industry. So manufacturing isn't just giant smokestacks, right? It happens at all these different levels. Moving to section 2, the backbone of development. Why is an entire nation's economic strength measured by this specific sector? The text lays out this fantastic quote: agriculture and industry are not exclusive of each other. They move hand in hand. I absolutely love that because it totally flips the script. Instead of competing for resources, the farm and the factory are actual partners in economic growth. You literally cannot truly modernize one without the other. So how does that actually work in the real world? Well, agro-industries, which are factories that process crops, give farming a massive boost by creating a steady, reliable demand. The factory absolutely needs the farm for raw materials, but it's a two-way street. The modern farmer wouldn't stand a chance without the tools the factory pumps out. We're talking irrigation pumps, chemical fertilizers, PVC pipes, heavy harvesting machines. It is just this perfect, continuous feedback loop of productivity. And it goes way beyond just helping out the farms. Manufacturing is essentially the magic key to a nation's broader prosperity. When you set up factories, especially in underdeveloped or tribal areas, you are directly wiping out unemployment and poverty by creating solid, reliable jobs outside of just agriculture. Plus, when a country can take its raw materials, turn them into high-value finished goods and export them, boom, that expands international trade and brings in a ton of vital foreign exchange. Okay. Section 3, classifying our industries. Industry is a huge umbrella term, so we need to break it down. The first way we categorize these places is by what raw materials they use. Basically, do you grow it or do you mine it? If an industry uses things like cotton, wool, jute, or sugarcane, it's agro-based. Pretty straightforward. But if it relies on digging up iron ore, smelting aluminum, or mixing cement, then it falls firmly into the mineral-based category. Next up, we look at their actual role in the economy. Are you building the tools for other factories, or are you making stuff for regular people? Basic or key industries like iron and steel plants or copper smelters are the foundational builders. They supply the essential raw materials that other factories desperately need. Consumer industries, on the other hand, produce the goods that you and I use directly every single day. Think paper, sewing machines, or even your toothpaste. We also got to talk about ownership. Who actually runs the show? You've got the public sector, which means massive operations owned and run by government agencies, like BHEL or SAIL, which historically focused on grand-scale national development. And then there's the private sector. These are driven by individuals or corporate groups, giving us recognizable names like Bajaj Auto or Dabur Industries. Now, the precise science behind mineral-based manufacturing is absolutely fascinating. For heavy industries, like an iron and steel plant, there's a highly specific recipe involved. You literally need a ratio of about 4 parts iron ore to 2 parts coking coal to 1 part limestone, 4 to 2 to 1. And because these materials are incredibly heavy and bulky, that specific ratio basically dictates exactly where these massive plants have to be geographically built just to keep transportation costs from going through the roof. Oh, and before we move on from classification, the text points out this really interesting geographic shift happening right now in the agro-based sugar industry. Sugar mills are literally packing up and migrating. They're shifting down towards southern and western states, like Maharashtra. Why? Well, it turns out the sugarcane grown down there actually has a higher sucrose content, so more sugar per cane. Plus, the cooler climate means a longer crushing season, and the cooperative business models out there are just highly successful. It's such a cool example of how geography and climate directly control where industries set up shop.
All right, Section 4, the environmental cost. We've talked about the economic wins. Now it's time to confront the unavoidable downsides.
The chapter is very blunt about this, and we absolutely cannot ignore it. These vital economic engines are directly responsible for 4 major types of environmental degradation: air, water, land, and noise pollution. It's the heavy, unavoidable shadow of rapid industrialization. Let's contrast 2 of the more invisible yet incredibly damaging outputs here. On one hand, you have air pollution, toxic gases like sulfur dioxide and carbon monoxide just spewing out, harming our lungs, killing plants, and even degrading buildings. On the other hand, noise pollution. It's super easy to just dismiss noise as a minor annoyance, but the text emphasizes that the constant, relentless grinding of industrial machinery actually causes severe physical effects. We're talking elevated stress, increased heart rates, high blood pressure, and even permanent hearing impairment. It's intense. Which brings us to our final section, number 5, finding sustainable solutions. How do we fix this without turning off the economic engine? Okay, get this. The source shares a genuinely startling statistic. For every single liter of industrial wastewater discharged, it pollutes 8 times that amount of fresh water. 8 times. To combat this, the text lays out a really strict 3-step treatment process. First up, primary treatment. This is mechanical stuff like screening out the big solids. Then secondary treatment using biological processes. Finally, tertiary treatment, which combines biological, chemical, and physical processes to actually clean and recycle that wastewater so it can be used again. As for air and land pollution, the fixes rely on a strategic mix of high-tech filtration and just straight-up strict legal regulations. Factories need to be retrofitted with gear like electrostatic precipitators and scrubbers to catch all that toxic particulate matter before it hits the atmosphere. Also, simply swapping out coal for oil or gas makes a massive dent in smoke emissions. And legally, we desperately need tight frameworks to stop factories from overdrawing our really vulnerable groundwater reserves. But listen, it's not all doom and gloom. The chapter actually holds up the National Thermal Power Corporation, or NTPC, as a prime example of what's possible. They're a massive power-providing corporation, but they hold an ISO 14001 certification for their environment management system. The whole point of highlighting them is to prove that, yes, you can have massive industrial growth and proactive environmental preservation happening at the exact same time. If you optimize your equipment and actually monitor your ecological footprint, large-scale industry doesn't have to equal large-scale destruction. And that brings us to the end of this explainer. I want to leave you with something to really chew on. We've seen how manufacturing is the undisputed backbone of our economy, but it clearly carries a very heavy ecological price tag. So the next time you go buy a new pair of shoes, or even just pick up a simple earthen lamp, take a second to think about the massive, complex systems that got it into your hands. How do we, as a society, balance our insatiable demand for economic strength and modern convenience with the environmental cost it takes to produce it all? It's a huge question. Thanks so much for joining me today to unpack this source material. Keep questioning, keep learning, and I'll catch you in the next explainer.